It's saying I'm live. We will see. I hope I'm really live. As always, I need to check. It seems I'm really live. So let's check the Webby. Let's check the YouTube. YouTube is working. And for the very first time, hello everyone. For the very first time, I'm also using Facebook. So let's check whether Facebook is streaming. And it seems it is. Okay. I assume it is working then. So, after this short technical introduction, hello everyone. In this super new series of webinars, or maybe we can call it live coding or whatever you like. So maybe you know me already from the previous series, which was about .NET GC internals. And that was super deep and concerning mostly the implementation details of .NET GC. So instead of that, after finishing that mini series, I decided to make a series of practical webinars. What can you use to make code more memory aware, and so on and so on. So as I'm super happy you are here today. As always, say from where you are, say hello, introduce yourself, and just give me any kind of feedback, whether you are hearing me well or not, because it is always a risk that something is not working properly. So just say hello and we will move on with this webinar. And today, as I said, it is a super very first webinar about of this series about .NET GC tips and tricks. And today we will cover those two topics which are just listed here. Yeah, so I will just explain them in a second. So maybe you don't know me already from various places, so let just me give you a few words about me. In general, I'm a .NET freelancer, trainer, consultant, speaker without any full-time job, which is all my activities are around .NET performance, scalability, internals, and advanced stuff in .NET ecosystem. So, for example, I'm an author of this Pro.NET memory management book. Also, I'm a founder of the initiative .NET is about this stuff. So we organize .NET meetups, conferences, webinars, and also online courses. So this takes most of my job regular time. Also, I'm a Microsoft MVP on the field of it is formally called Visual Development Tools or something like that. Development tools. In general, it is a development Microsoft MVP. You can find me on blog To Slow Exception or on Twitter. So if you like and if you will find something interesting, for example, during today's webinar, you can tweet it. I like Twitter a lot. So if you will find it interesting, just please tweet about it, because it will just help me to increase my visibility and to teach more people. I'm also developing this out-of-memory card game. If you are playing card games, this is something for you probably, because it is a card game about .NET development and also in this flavor of .NET performance, internals. So it's designed to be funny. And currently I'm still prototyping it. Stay tuned. Also, you can subscribe there, for example, for news about it, because I have huge plans about it, but not enough time, unfortunately, as always. And those are those initiatives, but also would like to mention the last one, which is just concerning me mostly recently, which is this .NET Memory Expert program, because I'm an author of this Pro.NET memory management book, and in general, I'm super interested in memory management topic. I decided to make this whole program about memory management for you. So there will be a lot of different activities like those webinars. There is a mailing list in which I will be providing you interesting information about memory management in .NET. So if you will find it interesting, you can look around at this page. Currently, what I'm proposing as a part of this program is a quiz. So if you are interested whether you know about .NET memory management something, what's your knowledge, you can evaluate your knowledge about this topic. There is a link to a quiz, and you will just have a 32 sample questions to test your knowledge. I'm trying to show there that you may know something, but probably not everything. So just try to take it, look around at this quiz. You will see what I'm proposing as a part of this program. And that's all. There will be webinars and other stuff here. Also an upcoming course, online course, as you can expect. Finally, I decided to make it. So stay tuned for news about that. But this is all not about me, but about .NET GC Tips and Tricks series. So I would like just give you a short introduction what it is or what it is not. So first of all, it is what it is not. It is not an in-depth explanation of the most important .NET GC parts. As you can expect, it has been already covered. As I said, there was a .NET GC internals series. In general, there was like 10 episodes, and in total, it takes 14 hours to cover all those stuff on YouTube, available for free for you. So this is already covered, and I will not talk about it here. This is already covered by me. So what it is, here I decided, as I said in the introduction, make a practical part, because that was very super theoretical and some internals implementation that most people probably don't care so much. So here is a series for practical development. So there will be practical debugging, diagnosing, measuring series. This is what I'm planning during these tips and tricks episodes. And also, even more interesting probably for regular, let's say, .NET developer, is to give you some best practices about programming in a memory-aware way, maybe some more interesting tricks, some advanced techniques that you can use, or maybe it is just good to know about. So practical side is the main topic for this series. I haven't decided yet how often it will be provided by me, but it will be something around 2 weeks probably, not on a weekly basis, but probably 2 or 3 weeks. There will be an episode about it. So it will be like interactive webinar, which should take about 1 hour, and I will have ad hoc drawings, live coding. Do not hesitate to ask, to interrupt, to discuss with me, to ask more, because I will be doing things sometimes, also improvising. So I would like to see more it more like interactive discussion, not the lectures that I'm talking for 1 hour and that's all. And I'm also planning to have various levels of various episodes. So there will be episodes for beginners. There will be episodes for advanced users. It really depends on the topic. We will see how it will evolve, but for sure it's not only for advanced .NET programmers. So just feel invited to share it with your friends that are .NET programmers and so on. So that's sorry, that's all about introductions. Today's agenda is about explaining 2 infographics that I was recently publishing in various places, and this is something that took this and previous week. And those are pretty advanced, let's say, tips and tricks. So I'm just decided to use this spiciness indicator that will show you how the particular tip or trick is advanced and how often you should use it. So the more spicy it is, probably less popular it should be in your regular everyday work. And as you see, today we are starting from the high level. So we have really spicy two tips that I will cover. But I've thought, okay, let's start from something advanced. We don't need to start from beginning, from the basics. For basics, we will have time too. So, hello, Andrei. Hello, Mikhail. Hello, Bertard. Hello, Kishan, Aaron, Piotr. Nice to see you all. And I hope at least one tweet will be tweeted during this webinar that you will spread the word about it, so maybe more people will come. I know there is so huge amount of various webinars and online activities that it is really hard to find time, but I'm super happy that you have found time for this one, and you are spending this time with me. Okay, so and the very first infographic, I published it last week, is about read-only-span trick with combination with the byte array. So this is the infographic that I published, and I showed you. I showed on this infographic that there is this, in fact, C# compiler trick that. Imagine that you are newing up a byte array. So we are just creating here a byte array of 4 elements, and we are assigning this byte array to a regular array local variable, which is var, which means it will be byte array simply as a type. And then just to use it, we need to do something with that. So for the purpose of simplicity, I'm just returning the first element. I know it is pretty stupid, like it doesn't make sense to return the first element. I know it is 1, but this is not important. Like the first line is here important, that I'm newing up a new array of bytes. And this obviously allocates this array. So we are seeing that with the help of benchmark.net, we are seeing that this takes some time and also allocates 32 bytes, which is the size of this byte array. And then there we have a second method, which is creating exactly the same byte array, but instead of assigning to a local variable of type byte of arrays, we are assigning it to the read-only-span. And this seems like a magic, that the only difference is here. Like here we have a var, and here we have read-only-span of bytes. And the difference is huge in terms of the memory usage. Like it means we haven't allocated this array at all. As we see from the benchmark here, no array has been allocated. And because of that, this code is super fast, because in fact it is doing almost nothing. Like it is accessing some array from somewhere and returning the first element of it. So it seems like we have kind of magic here, that only by the type of the local variable we can influence our code so much that we allocate an array, or we are not doing that at all, which seems a nice optimization. And this is indeed, it received pretty a lot of interest on Reddit, for example, or on Twitter, because it seems like super interesting trick, why it is happening, how it is working, and so on and so on. So now, because this was only an infographic and I was trying to explain it in a few places, this webinar seems to be a super nice place for doing that. So first, how it is working. So as you see, we are for sure, we see here that something, some magic is happening. Some element of this whole ecosystem is discovering this pattern that we are creating a byte array and assigning it to the read-only-span. The question is, who is discovering this pattern? And the answer is and it is a C# compiler doing that. So if we look at the Roslyn implementation, because Roslyn is a C# compiler, and where I have it, this, I was clicking it, and I don't see. I don't see it. Okay, I will just close the full screen then. Okay, so the magic happens in the Roslyn. Roslyn is the C# compiler. It is open sourced, so we can look around in the code. And in the end, as you see, we are looking at the .NET Roslyn repository on GitHub. And there is a compiler, C# portable code gen emit expression CS file, which is the pretty big file responsible for emitting IL that will for a particular code that it is during the compilation happens from the when converting from C# to the IL. So we have this emit expression, and we have various methods here. And for example, we have emit object creation expression. So as you can see, this is a method called when the Roslyn is emitting code. Where it is, where the Roslyn is emitting code for object creation. So every time you have new something in your code, so in the end, every time we have also new byte or new anything else, the emit object creation expression is being called during the compilation. And obviously there are some checks, interesting checks, and then we have another additional if here inside this method. If we are here considering the expression of type read-only-span, as we saw, it is indeed read-only-span, and if there is only one argument, like it is a array, then of one single dimension, so exactly the case, then it is trying to emit read-only-span as blob, a special case for emitting code for this particular scenario. So as we see, Roslyn is simply discovering it, and it is only happening when we assign it to read-only-span, which happens here. That's why it is discovered. An array and object creation, which is assigned to read-only-span. So let's look to this try emit read-only-span wrapper. And here we have it, and we can see what's happening inside. So there we have a check again, whether we indeed are interested in read-only-span of T, whether it is an array, and whether it is an array of special type, which is in size in bytes of 1. So in the end, we see here from the code that this will happen only for arrays which has element of size of 1 byte. For anything else, it will not work. So it will not work for arrays of characters, because characters have 2 bytes. It is not working for array of integers, because integers have size of 4 bytes, and so on and so on. So this magic works only for a byte array and signed byte array and bool. As far as I know, we will check. Then if it is true, then if it is not true, if it is size is bigger than 1 byte, we just saying, okay, it will not happen. We cannot do the magic. And the comment here is interesting also, because everything is here about the endianness. So we cannot by default do this magic for types which are not 1 byte in size, because the little or big endian format will just influence the result. So we cannot do this magic for bigger types because of this unfortunate endianness of data types. Okay, but let's say it is 1 byte. So we, for example, a byte array we are trying to create, and then all things are happening, which will just make this blob and other stuff that I will show you soon. So it was only to show you those those conditions. So as we see, we have in Roslyn in the end this code that is emitting a proper magic code that will not allocate this array at all. So the first answer is, okay, so the compiler is responsible for that. It discovers it during the compilation. So it is not JIT, it is not anything else, it is Roslyn that discovers that. And let's look at the code again. So we have here exactly the same code that we have seen previously. And let's look what is happening underneath when we are making this code, when the compiler is doing this code. For that, we can look at with the help with sharplab.io, which maybe you know, maybe not. It is super nice tool for the compilation, an online tool, and connection lost is not a good. It is a tool for decompiling C# or Visual Basic or F# to C#, IL, or assembly code. So let's copy paste our methods here that we are going to investigate. And it is working very slowly, unfortunately. I hope it will. Connection lost, reconnecting, doesn't look good. Just try it. Try open it in a second tab. Hmm. Not good, not good. We have. Yes. Okay. But it is online tool, which is sometimes good, sometimes not. As you see, I don't. Sharplab.io is not working. That's not good. It is also open source, so we can also look at the code, what is happening, and we can ping Andrei on Twitter to say that we are doing live demo and the Sharplab stops to work. Okay, so here we have it, the first scenario. Let's try to look at second, maybe it will work. Okay, so we have those two examples. On the what is in the end happening here? So first, let's look at the C#. So we are decompiling C# to C#, but it also allows us to see something interesting. So first of all, the first example, when we are just creating this byte array in a regular manner, we are seeing that, okay, this in the end consists of two steps. First of all, we are really allocating this array. So we are newing up a new array. And then there is seems to be a special call called initialize array, and it is initializing this array from some data. So it means this array will be allocated empty, and then we are pasting, let's say copy pasting those bytes that we know that should be there inside this initialize array special method. But okay, that was the regular allocation. When we are doing this read-only-span trick, it seems that the magic happens here, which looks like that. So it is not formatted well. So I will open Notepad simply to show it in a better way. So this is the code created for the case of the magic case. So in the end, what is happening that we have here using this unsafe class, we will return to the unsafe class probably many times during our series. Unsafe is a class with many fancy magic methods. And here we have a fancy method which is converting a reference to a pointer. And this reference that we are taking to convert to a pointer is having very strange name. As we see, it is a field with this super cosmic name of the class with even more cosmic, even like strange name. On the IL level, we can have types that consist and contains those signs. On the C# level, it is not possible, but on the IL level, we can. So the Roslyn is emitting this type with this special name just to make sure no one will be able to emit something like that, because the C# compiler prohibits that. So in the end, what we is doing here, we are creating a new read-only span. Read-only span is a I haven't explained the span and read-only span. There will be time for that for sure. But read-only span for now we can just describe it as a description of the part of the memory. So read-only span, and span is just a type describing a memory region where there is a pointer when we are saying here it starts, and also it consists of length. So we are saying this is a memory region starting here with a given number of bytes elements. So read-only span accepts a pointer to say from where we are starting. And it seems that this is the pointer that we are providing it. So a pointer to this field magic with the magic name, and the length is 4 because it is the length of the array. So in the end, we have this new read-only span created. Then we obviously return the first element because it is what the method was doing, but it doesn't matter. Like it is like or something like that. And that is interesting part. This is not interesting. This is for purpose of the example. But this is the way how we are creating this read-only span. And this is the code emitted by this magic Roslyn condition that we have seen in the code. Okay, so what does it mean? What is inside this super strange field or property or whatever? We will see. So there is, as we see in sharplab.io, in the end, there is this special class with this special name, and there is static read-only field with this super strange name, which is not able to be compiled to the C# because C# does not provide the way of expressing this underlying technique used here. So we need to switch to the IL, and inside the IL we will see that, okay, this field with this super strange name is using something which is called byte array, and with this data metadata additional tag. So this is something that is not exposed to C# directly, but it is possible on the IL level, a way of inlining data simply. And this data is saying that here we are saying we are inlining those 4 bytes inside our assembly. Those 4 bytes should be inlined in our assembly. And with the help of this super strange name, we can then refer to it, access it, and so on and so on. So it seems okay on the IL level. It is really working like that. And with the help of and then, as I described, it will be the read-only span will be initialized to the pointer to this inlined data. So this is what is happening in underneath in the end. So this special data part of the class is inlined into the binary assembly file, And then it is obviously loaded to the memory because we execute our program, so our assembly is loaded into the memory. So we know perfectly where this byte array is living inside our assembly file inside memory. So with the help of this code, ReadOnlySpan can directly refer to it with the help of the ReadOnlySpan can directly point to this memory inside our assembly. And because of that, we don't need to allocate this array. This byte array is there inside our binary file living in memory, and we are accessing it with the help of ReadOnlySpan. ReadOnlySpan can represent any memory, any pointer. So here we are using this to represent the memory inside the file that is loaded to memory. If it is not safe, sorry, if it's not safe, if it is not, if it is not like, if you feel it is too difficult or maybe you don't still understand it, just ping me, ask. I always do not hesitate to ask simply. So in the end, that's the magic happening here. As a summary, Roslyn is discovering this pattern that you assign a byte array which is already initialized with data, and then you are assigning it to the read-only span, and because of that, Roslyn is detecting that, and it is emitting a code that will generate this blob, because we call it blob, the blob that will contain this data inside the assembly, and also emits code that is wrapping this memory to the read-only span. One question I'm seeing from Piotr. So it is marked as unsafe. That's true. It is marked as unsafe not because of read-only span, because in the end, one of the benefits of the span and read-only span is that it doesn't require, say, unsafe code, but it is because we are using pointer. Underneath here, there is a S pointer, so we can say that underneath we are using pointer here, and unfortunately for that, we need unsafe code. So it is more like pointer, something like that, that is happening. And because of that, it is unsafe. Yeah. And that's the whole magic. So in the end, as you see, this is a pretty nice way of avoiding allocating anything if you are having an array of constant elements. Maybe it can be also, for example, signed byte, and also let's check bool. I haven't checked that. Yeah. Now I need to destroy the perfect example. False, false. And yes, also working for bools. So for all those three types, you can use this trick to avoid allocating this constant array. That is constant, you know that you have those values, you will need them, so you can avoid allocating it totally. The question is, what is the JIT result? So let's look at it. I hope it will not stop to work again. IL. IL. And the JIT result, we will see what is happening underneath with the help of JIT. So yes, this trick has received 4 papers from me because it is pretty low level, as you see, like I'm claiming the details, but in the end 4 papers because it is not super common that you have such array, like creating a byte array with constant data inside is not super common. So you can save indeed allocation here, but it is not so common that you will benefit from that. The question is why it is so super faster. Like we saw that it is okay, it is not allocating, but the difference was like few hundred times. And this is because here we see the difference between the JIT code. So create2 is not doing at all in the end, or almost, because it is just like the JIT knows where is in memory this inlined array, because it knows where the file of assembly is living in the memory. So it perfectly calculates the address of it, and it just accesses it, dereferencing the element and putting it to the register. So it is just a single access to memory that the create2 is doing, because it is just accessing the memory under the given address, while the create1 is obviously allocating the whole array. So it is here we see the code for allocation of this array, then we are consuming this array. So it is much more code. Even the allocation here is the huge huge difference comparing to the fact that here we are not doing anything almost. It is just accessing a single pointer. So from there we have this the difference. So yes, that's the difference, the huge difference. When I was showing this, and I'm seeing even here that Vitaly is also having this concern that in this scenario that I've published in an infographics, it seems that someone, maybe JIT, maybe compiler, should just detect that in the end I'm just returning 1. And probably it should happen. Maybe someone, probably compiler or JIT, I don't care, I don't know, should detect that in the end I'm just returning 1 always. But this is the level of sophistication of JIT or the compiler. Currently it is simply not happening. Like, it is maybe easy to say that from this particular example that it should be detected. I expect that doing that in a general safe manner is not trivial. So this constant folding is not happening here. But it doesn't matter. Like, as I said, it is just for the purpose of example, you can even imagine that you have code like that is just consuming this array for something, and we don't have this problem then. It is all about how this array is being allocated or not about what we are in the end doing with this array. It will be always working no matter what we are doing afterwards. So yes, that's the thing. If you have any concerns, do not hesitate to ask and discuss. What I would like to present you more is, okay, it seems that it is super nice trick, but there were also concerns. Okay, but most typical, like any normal, let's say normal .NET developer will not use this trick, but if it has something like that, it will put it inside a static field. That I will just, okay, one more thing before that, I forgot to mention that. One can ask, okay, but what about the span? Because here I'm assigning it to the read-only-span, and then the magic works. What if I assigning to span? And if we will see that inside the sharplab.io, this trick will not work. Obviously, we know it will not work because we saw the Roslyn code checking whether it is read-only span, but we can confirm that in sharplap.io, if we are using it with the span, something exactly like for the first case happening. So we are newing up this array, we are initializing this array, and only then returning it, wrapping it as a span. One can ask, why is the difference here? Why the read-only span is so different to this comparing to span? And one of the answers is you need to remember that this trick is referencing a memory inside your assembly file, the binaries of your assembly file living in a memory. So read-only span prevents any modification, while if you would like to use the same trick with span, now out of a sudden you will have an access to modify your assembly file, which seems not so safe. Like, it is super not safe. Like, we have now a pointer represented by span to your binary file, and then you can try to modify it, go out of band and try to modify even more. So it is safer to expose it by default as read-only memory, not as a regular memory. That's one of the reasons. And also, okay, but that's the difference that I hope you feel. Another thing is that a lot of people were saying, okay, but that's a super, like, we are not doing something like that. If I know that I have an array of constant values, I would create simply a static array. And that's a valid point. Like, probably typically you would do something like that. So if you know that you have, I mean, if you care about memory, you can do something like that and allocate it every time when the create one is created, which may be a problem or not, depending how often you call create one. But if you know that it is something on the hot path and you are calling create for often, then you will probably wrap it inside the byte array, a static one, a static field, which will be just creating these arrays once, and then you will reuse it for your purposes. Here I'm just returning the first element, but as again, it doesn't matter. So yes, typically you would do something like that. The difference is one, and that this code is not, as you already saw, not allocating anything. So you are simply referring to the binary file without any allocation. Here we have this difference. This array will be allocated once and will be referenced by this static field, but it needs to be allocated. It will live in managed heap. It will take some memory. So depending on the size, it may be a benefit or not. But if you have a code that is on hot path and you can get rid of allocation totally, why not use it? Like, it is only a matter of using it as a static field or a matter of using it as a read-only span. So here, it is a matter whether you want to have this array in memory on the managed heap or not. That's the difference. We can also look at the code generated in this scenario. So let's copy paste it to the sharplap.io. And let's look what's happening there. So obviously create for is a trivial operation because it is just returning this array. What's changing here is that in the end, the static constructor of this class will need to initialize it. And as we see, it is exactly the same code as for any other regular array initialization. So we are newing up this array once, initializing it with data, and assigning to the static field. So it is a difference here. Whether you want to have this array on the managed heap or not, totally avoiding any overhead because you will just refer to a constant data inside your assembly. So I agree. It's 4 papers, 4 papers, because it is pretty niche and edge case that you would like to avoid this memory being used by such array, but it is used by, for example, the one of the best sources to check whether something makes sense or not is to check whether .NET team is using it or not. So let's look how it is used by .NET team itself. One of the use cases will be there is one interesting use case, the memory-free initialization helper. So there is a code inside the web utility constant static constructor. Web utility is just a utility of tools for web processing, and there is a PR that is doing interesting thing because of introducing this trick, it is reducing the code size from 16 kilobytes to 200 bytes. So it is like reducing the size of the generated code by 2 orders of magnitude. It is pretty interesting because, as you see, this change is used here for something totally different, but we are not here reducing the memory usage of the managed heap, but the code gen, so the code that is being generated by the JIT. How it is happening? So an example, what was previously this code was looking like that, and in general it is all about having a dictionary of special characters that needs to be specially encoded in case of URL encoding and so on. So we have this pretty big dictionary. Because it is before the change. We have this pretty big dictionary, which is called Lookup Table, and it is simply for remembering the encoding of every special character that needs to be encoded in the web context. So we have pretty exotic ones here, but we should probably see also pretty common ones. And then it was the code. Like, we have a pretty straightforward code. We have static dictionary, and this dictionary have, as far as I remember, over 200 elements. And with the help of this code, we are converting every such special name to long, and remembering how it is being encoded in the character. And this takes a lot of lines, because obviously we have all those over 200 elements. So the change was to use this special trick, and to create an encoding table inside as a byte array. So instead of the dictionary, the dictionary will be populated, but instead of that, we are keeping all the data needed to initialize the dictionary in our special byte array. And this is, as you see, exactly the same trick, a byte array assigned to read-only-span. And here we have exactly the same information, like those over 200 lines, just with the already computed value of the encoding of the name, and the result, how it is represented as a character. Exactly the same data, but inside the byte array. And as we know already, this byte array, although pretty big, because it is few kilobytes probably, then it will be not allocated at all, because it will be just referenced from the binary file directly. And then we are using this information from the binary file directly to initialize this dictionary with the help of a simple loop. So we are just simply iterating through this array, and populating it with the data that we read from it by few bytes by few bytes. We are reading the proper parts of this byte array and populating it, the dictionary, with the help of it. Why does it change the size of the code being generated by JIT so much? I prepared a simple example that is doing the same but in more controlled way. So we have exactly the same code here, and but for only few elements. So here we have the first method, and this method is doing exactly the same. Its goal is to initialize the dictionary with some data, and how it is being translated to the IL. As we see, it is just nothing super interesting, like it is just newing up our dictionary and then populating it element by element. And on the IL level, it looks like that. It is a long and boring list of calls to the set item methods. So that's why the code generated when you are initializing over 200 elements is pretty big, because we have this part duplicated over 200 times for every set item. And on the assembly level, it looks the same. So for every element, we have few instructions multiplied by over 200 elements. It generates pretty long code. While obviously the same trick with the help of the loop is much smaller, because we have here this super magic array of data, and then we have our while, which is just key by key populating our dictionary, which results in a much smaller code, because it is not depending on the size of those elements. In fact, not depending on the count of the elements. We are just accessing this array, and then we have a loop that is iterating through those all elements and populating the dictionary. So in the end, the code of method 2 is much smaller, and the difference will be the bigger, the more elements we are initializing in that way. And moreover, the size of this method will not change, and will be not depending on the number of elements, while this will be bigger and bigger the more elements we have. So this is like nice example how we can optimize the JIT size, the code that is being JITted, and also nice use case of that the team is using this trick to just inline all this data inside the assembly and don't care about memory, because it is just not being allocated at all. So it is the first use case, first example. The second one is that obviously it works also for static fields of ReadOnlySpan. So you can create a helper and combine both, in fact, both techniques, and have a static ReadOnlySpan field, which will be just using your magic inlined data. So now you have a read-only-span of bytes representing memory in a file that is not using this array, not allocating this array. And here we have an example from the HTTP HPACK class, a namespace, which is for HTTP2 HPACK protocol, which is for packing headers. And here we see that we have pretty long number of fields for representing, for having a byte representation for every possible status code of the HTTP2. And all those arrays will be not allocated on the heap at all, as we already know, because of this magic trick. Pretty often we will see also in comments that this particular set of instruction is using our Roslin magic trick, just to explain why it is done like that. So here we have the HPACK example that is using exactly the same trick, and then we can utilize those read-only-span inside our serialization, deserialization stack of the HTTP2. but all those arrays will be not allocated. And so example, I have also some sharp.io example. This is exactly the same scenario. We have here a byte array created, assigned to a field, and a method which is just using this field. And as you will see, there are no allocations. Again, it is just referencing our array, accessing the element, initializing it to a span, and because we have an array of 3 elements, we see here that in the end read-only span with the length 3 is being created and returned to the caller. So no allocation again at all. And by the way, I haven't mentioned that, but all these presentations will be available, so you will be able to click, look around, and use the same examples that I'm clicking here. So in the end, where you can use it, like if you will try to find inside the .NET runtime and .NET libraries repository, you will find something around 60 use cases of this trick. You can use this you can use this regex inside the .NET runtime repository to find all the cases when exactly the same trick is being used. Or you can use a little bit different regex to try to find a place in your projects whether you are having a place when you can benefit from it. So every time when you are newing up a byte or as a signed byte array, and assigning it to the var or the just byte or to span, then you can use this regex and try to find your own places for your own improvement, because maybe you have something like that. I don't expect so for peppers, because it is pretty niche use case and pretty advanced, but still it is worth to know that something like that is that such a magic is happening. So I hope I've explained it a little bit. If not, as always, you can ask. So that was the first infographic, and I have 3 minutes for the second one, but probably I will just make it a little bit longer than 1 hour. The second infographic was about SkipInit locals, SkipLocalsInit and Unsafe.SkipInit. So that was the second infographic, when you have this possibility with the help of SkipInit method that this variable does not have to be initialized, because C# compiler is enforcing, forcing in fact, initialization of every variable before it is used. And also it is forcing for initialization of out variables, like here, out arguments, sorry. So with the help of SkipInit, we can get rid of it. And additionally, we have SkipLocalsInit attribute that can nicely work all together with the SkipInit method. So what we have there, how we can use it. So first of all, few things, like if you are writing a code and you have a struct, for example, and you would like to not initialize it, it is not possible. Like if you will write something like that, obviously the compiler will be complaining that you are trying to use an unassigned local variable. So even if some cases you don't need this value, you cannot omit initialization of it because the C# compiler is forcing you to do so. Obviously, to overcome that, you can explicitly say that I'm initializing it with the default value, which now is initialized, which means it is not something we would like to achieve. Like maybe I would like not to initialize it at all. Here I'm initializing it explicitly, so it is not the thing that I wanted to achieve. SkipInit allows us to omit this requirement. So as you see here, I'm using quit and the compiler is not complaining about that. and I'm just using not initialized GUID variable. Here I'm using this consist syntax for doing that. I could do it also like that, as far as I also, this is the second possibility. The goal is that SkipInit says, okay, I don't care about initialization of this particular variable. And now calling this is pretty strange. Like you are calling get hashcode on a struct, which is not initialized, which is by default, it means it is not zeroed, which means it is initialized with some random data that was at the place when now this local variable is living. So get hashcode on it will not destroy your code, will not call any, throw an exception. It is just saying what was there before, I'm treating it now as GUID, and I'm calling get hashcode on it. So kind of random value will be generated here. So you can imagine some scenarios that you can benefit from that, simply that your variable doesn't have to be initialized. I will show you an example soon. But another use case for that is to combine this possibility with this SkipLocalsInit flag. So SkipLocalsInit means I'm forcing saying explicitly that I don't want to initialize anything. So in the end, yes, I really don't care whether this GUID has been initialized or not. So I would treat this as fooling the C# compiler that it is not caring about initialization of it, but it is an implementation detail whether it in the end will be initialized or not. Probably it will be still. But by using this attribute, I can force I will not initialize local variables in my method, which means if I'm using this SkipInit method, it will just not initialize, really not initialize our GUID, because now I'm skipping local initialization of every local variable and explicitly saying that I omit initialization of GUID. So this will produce some results depending on like these are some super simplified use cases for you, what you can do with the help of this combination of those two elements. Let's just look in a few seconds how it is working underneath, what are the differences. So I hope Sharplab will be behaving better now. And what is interesting here is obviously not the C# level, even not the IL level, because on the IL level it is all the same almost, but the JIT level. So at the JIT level, we will see that the local frame of this method, the one that is keeping the state of variables, is zeroed in this case, and that's expected. Like in the end, we are using here a regular method, so it is zeroing everything, initializing everything. So we see here those two instructions that are three instructions, in fact, that is zeroing the stack, zeroing all local variables. As I mentioned, we see the same in case of the regular method with our trick, which fooled the compiler, but in the end, JIT again decided to zero this stack frame because it was willing to do so. Like if it is, I haven't said that I don't want to zero the stack frame, so it is zeroing the stack frame. Only when I'm combining it with the help of this SkipLocalsInit, I will see that yes, in this case, there is no stack zeroing. There is simply direct usage of this GUID, which now for sure contains some random data, no stack zeroing. So what are the benefits? First benefit is that this method by itself may be useful in some specific edge cases I will show you soon, just to relax this requirement that you need to initialize every local variable. And this is not for performance, but for the code flow, let's say. And additionally, if we are using SkipInit with the help of SkipLocalsInit, or we are just using SkipLocalsInit by itself, it will just say, I don't want to clean the stack of the method before when it is called. So it is for performance, because zeroing the stack is a cost. So when you are calling this method super often, you are just getting rid of the overhead of zeroing the stack. So it is for performance. SkipLocalsInit is for performance. So okay, there are some use cases, as I said. The first one is for the code flow, not for the performance. I would like to call it don't initialize in case of failure. The first example is the one that I presented on the infographics. So we have this try do something pattern in .NET, which is by convention saying that my method is trying to do something. It answers, it returns a result, whether this something has happened or not, whether it was a success or not. And if it was a success, I'm passing the result as an arguments, as an out parameters, which means they will be populated from inside my method. By the convention is also that if it is not succeeded, like it failed, I will return false, and I should not use those values, because it means those values are not populated. Something has wrong has happened, something bad has happened. I haven't managed to populate those data, so I don't care what is there. So I can do that with the help of SkipInit, that in the end those values will be not populated, because if I would like to do that manually, like here, I cannot do something like that. So I cannot say something like that, because the compiler will complain. In case of the success, in case of returning true, I'm populating this data. But in case of the failure, I'm returning false, but the compiler is complaining that out parameters were not assigned. So I have unfortunate case that I don't care about those values, because I'm saying to the caller that it hasn't succeeded, but I need to fill it only to satisfy the compiler, and it will be something like that. I will be just initializing it with some dummy data just to satisfy the compiler, why I don't expect anyone will read this, because it knows that this operation hasn't succeeded. So it shouldn't be, the values shouldn't be used. And this obviously is kind of cost if we are calling this super often, initialization with some dummy data. And we can overcome that exactly the same, that scenario with the help of Unsafe.SkipInit. So we are fooling, let's say, fooling the compiler, that are maybe just explicitly saying that I don't care about initializing those values, and now it will compile. Whether, although it is those values are not assigned in the case of failure, the compiler is happy and it will compile. And we will benefit from that even without using this attribute. It will be just for the code flow, for our like not assigning some dummy data which are not important for us. And we can even benefit a little bit from performance, because we will get rid of this assignment of dummy data. If we combine it with SkipLocalsInit, we can benefit even more, because we will not zeroing our stack frame here, so it will be a little bit faster. And as you saw on the graphic, the difference is not huge, like it is 2 nanoseconds. But again, this is 5 peppers. So five peppers means it was for super hot path code that is called super often, and we are really caring about those 2 nanoseconds, because it is called so often, it just accumulates to a nice benefit in the end. And so don't initialize in case of failure is one of these use cases. It is used in GitHub repository again. So we will see examples of that. Like, for example, here we have a method inside the UTF-8 parser helpers. And there is a method, helper, for throwing an exception if something bad happens. And just to satisfy some probably expected signature, we have those out parameters which could be used, but are not used because we are just going to throw an exception. So we are using SkipInit just to satisfy the compiler, because we are just about to throw an exception, as the command says. So this is one of the use cases that we can meet inside the .NET Runtime repository. By the way, F# is allowing us to just omit it totally. So it is just the code that we would expect to have in C#. It is magically allowing us not to set the values in case of the failure. We don't have to assign here any dummy data just to satisfy the compiler. F# is more forgiving for this scenario. But it is F#. Unsafe init may be helpful in case of C# code. So it is the first use case. The second use case would be to combine it with the unsafe magic. So I have another example from the .NET runtime. We have a set of try-parse methods. Try-parse is exactly the same flow, like the same convention. It is trying to parse a string to a given type, and it will result true or false depending if whether it was succeeded or not, and the value will be populated if it is a succeeded operation or not if it is not succeeded. And here, as you see, we are doing some magic with the help of unsafe. And what the C# compiler is expecting when it sees a method with the out parameter is that this out parameter will be assigned. But here, unfortunately, due to the signature of the unsafe as method, it is not expecting out parameter, but a reference parameter. So from the perspective of the compiler, this parameter is not set because it is passed by reference to the unsafe as. What is happening here in the end is that this try-parse wrap method is kind of wrapper. It is delegating parsing to the type here with the same string, but it is reinterpreting things. Like it is saying, okay, I'm expecting the result, which is of type unsigned integer pointer, but I would like to parse it as a native unsigned integer. So I'm using unsafe as a kind of reinterpreted cast. So I'm now starting to treat our result, which is of unsigned integer pointer, and I'm treating it as a native unsigned integer. So the unsafe as is doing this cast, expecting a reference to the unsigned integer pointer. So here we have it here, and try parse is then setting this as a result simply as a non-native unsigned integer. But as we see here, the compiler is not satisfied, because if we just leave it like that, the compiler will say you are using an unassigned out parameter, because we are trying to pass by reference here our result, which is in the end, in fact, unassigned, because the compiler doesn't understand all this magic with this method, that this method in the end is only casting this pointer from one type to another, so it doesn't care about. Okay, I'm it's super dark. Okay, just a second. Okay, I'm back. Sorry for that. I just totally forgot about this aspect. Okay, so unsafe as is underneath only just reinterpreting a reference from one type to another. It really doesn't care whether this is assigned already or not, but the C# compiler doesn't know that. So we need to say explicitly for the compiler, don't be worried about that. Just treat it as just skip initialization of it, and now the compiler is really happy, and it is compiling this method, which by the end is super nicely translated to the JIT level. Like, as you see, we are doing here a lot of some kind of unsafe magic, and for sure I will have an episode about unsafe because it is super nice topic, so I feel it will be nice to cover it. But as a kind of spoiler, as you see, JIT is really able to detect a lot of these patterns, and in the end, all these unsafe casts here are in the end just translated to a single unconditional jump to the try parse method. So that's nice. But that's really advanced stuff that I will cover in the next episodes. But this is why one of the use cases of it. But both those use cases are pretty magic and really deserves 5 peppers. I would say that SkipInit was also introduced for another use case, which is not so magical, and this is about fooling the Struct constructor. So let's say the example. Let's see an example of it. Fooling the constructor of the struct. I will just make a short example of it here also. So let's say that I have a struct, and sorry for a little delay. We are slowly ending, so in a few minutes, like 10 minutes more, and we will be done. So we have a struct, and we have some fields like int e one and another. And when you have a struct and it tries to initialize the fields, there is this constraint on the C# compiler level that all the fields needs to be assigned. So if you have a struct and this struct have some fields, every constructor must assign every field. That's the requirement of the C# at the C# level, forced by the roasting compiler. So now we are complaining, okay, our constructor is not assigning this field, and it must be fully assigned. So, okay, that's valid point probably. We don't want to have here any random data. We need really to assign everything. But there may be some cases then I really don't care about assigning everything in this particular constructor. For example, I know I will not use other fields. And for that, we can use the same magic with the SkipInit. But we will say I skip initialization of which is I skip initialization of the whole struct. And now the compiler is happy. Like, okay, I'm skipping the initialization of this, which is our struct, so I don't care. You want it, so you have it, and you are initializing only a single field, which is pretty obviously unsafe in terms that now if you will try to read this variable, this field, we don't know what will be there. Something will be there, but when it may be useful. First of all, you may have some specific cases when you in the end are not assigning your values field by field like here. This is nice and pretty basic code, but you may be having some methods that is, for example, able to initialize the fields. And this is an example in the vector class of the private core lib. There is a vector struct. This vector has a constructor that is accepting a value. And this constructor constructs a vector whose components are all value. And as we see here, this is like using some magic method to set those elements of this vector. There is no direct assignment of every field of this vector here. So without this method, this will simply not compile, because the compiler will not know that, okay, this particular method somewhere inside is initializing our struct with all the fields. So we are just saying here explicitly, dear C# compiler, don't be worried, it will be initialized. But now I'm just explicitly saying it is not initialized. It doesn't have to be initialized at this point. So this is one of the examples, and I'm calling this fooling the struct constructor, because we can split it now that the constructor doesn't have simply to initialize all the fields, period. This is also useful in another trick when we would like to treat structs as onions, probably onions. So this is a typical scenario when you will be interested in, let's say, treating a struct as an onion. So another example from in this case from the WinForms, rest in peace WinForms. no, WinForms are still used for sure, but WinForms repository, when we have a struct, which is an kind of discriminated union, or any, like you would like to call this, when you have a struct with the explicit layout, which means we have 4 bytes lying in the memory next to each other, and we have this blue, green, red, and alpha channel values treated as a byte. But also with the help of the explicit layout, we are saying, okay, but I have also a field of type integer at the same offset, at the offset 0. So now we can treat our struct as a 4 elements, 4 byte fields, or as a single integer. And this is like those fields are overlying in memory, but this is a pretty nice, convenient way of setting the value of a color in terms of 4 components or as a single value. And if you'd like to use this as a struct, as an onion, then you need to have this SkipInit, because obviously if you have a constructor that accepts all those 4 bytes, you are setting those 4 fields, but you are not setting this field of the value field, because you will just overwrite what have you set with those 4 values or those 4 assignments. So this constructor is not setting a value, and the constructor setting a value will not set A, R, G, and B fields. So in both cases, we need the SkipInit just to say, okay, I know what I'm doing, and I'm skipping in some fields being initialized in my constructor of the struct. So this is not for the performance, but rather for the possibility of writing something like that, possibility of writing onion types that are just for that. They are reinterpreting some fields that are overlying in the memory with the help of the field offset, and the SkipInit is just a convenient way of writing such constructors. And by the way, obviously, this is pretty often that you would like to express a color as 4 components or as an integer, because if you have ever write anything in front end, you know that pretty often we express colors like that, so it is an integer. So that's why it is nice to have two ways of expressing colors, both as a 4 components or as a single integer that will be just there. And if we use this constructor with such a value, obviously those bytes also will be set, because this is overlying in the memory. So this is an example of the SkipInit. And I'm slowly ending, so if you have any questions, it is a very good time to ask questions now. And so this trick has 5 peppers, the maximum, because as you saw, it is pretty low level thing that should be used only in super hot path, at least if you are using this trick for the performance, or if you are writing the structs and would like to treat them as onions, onions. I'm not sure why I'm not sure how it should be spelled, but let's assume it is onions. So then maybe this spiciness is a little bit smaller, because it is then not for the performance, but for the code pattern that can be used for such a purpose. But in the end, really treat it as something for edge cases that are not so often met in your regular code. And this both applies for both infographics. So it is really, there were many comments like that, obviously, on Reddit or somewhere else, that we should not care about the code that is just making us our code faster by 2 nanoseconds. I agree, most web applications will not benefit from that. But we are not writing only web applications. That's the first place. Sometimes you are writing low-level code. Sometimes you are writing a library which is maybe used by many and you don't know by who. And then you are really concerned about the performance of it. Maybe you are using your application in so intensive way, or this method is called on a hot path, called so often that it really will matter, even if it is a 2 nanosecond in case of a single call. But this is a topic for a separate webinar probably. So so that's why I will stop at here on the topic on what level of performance we should be concerned about. So those two things that I covered today, and now the time for you for questions. So will those use cases have any changes with IoT compilation? So that's a good question. Like IoT compilation is just a kind of explanation for everyone. And that's, by the way, again, super nice topic for a webinar, is a way of compiling your application in advance. So it is not using JIT, but your code, the IL produced by the Roslyn compiler, is then simply converted directly to the binary code, to the machine code, and executed as any regular native application. So there is no JIT. Your typically, at least most of the application is not being JITed, but it has this native code already in place and we are executing it. So the difference is in case of IoT that the JIT, this part is the difference, because if the Roslyn trick is doing something like we have seen in case of the ReadOnlySpan, then it will be in the Roslyn, and then obviously ahead of time compilation doesn't change anything. So this will apply for IoT also. Like this is something that is on the IL level, and for sure will be interpreted in the same manner for in case of IoT. Because it is on the Roslyn level. And the case of this SkipInit, that's probably the same. Like fooling struct constructor is just a kind of semantic meaning for the C# compiler, so yes. And unsafe magic, the same. Skipping initialization with the help of SkipLocalsInit, that's really depends on the IoT, what it will be emitting for such a method with such a attribute, but I would expect it to do exactly the same because it is the attribute for that. So in the end, the answer is yes. I believe all those use cases will have the same sense and will have sense also in case of IoT compilation. Next question. Is it your webinar number 1? Yes, I'm creating a new series. So it was in the introduction, a series about practical debugging, diagnosing, measuring, and even more importantly, about various best practices and programming tricks, all about .NET Memory. So this episode was pretty advanced, I agree. There were 4 and 5 pepper tricks. There will be episodes for much less advanced topics, for basics, and I'm expecting this series will be pretty long, so I'm not limiting myself in any number of episodes. It will be as long as I wish. So I expect even months and more, as long as I will be not tired by it. So yes, in the end, it is a new series. So please be invited to follow on Twitter, subscribe on YouTube, whatever way you will be. And I also said I'm targeting like 2 or 3 weeks period between episodes, not the weekly basics, because it would be probably too much for me. C# is so improved. Do we still need the keyword unsafe? In which case do we still need it? So unsafe is still needed in many cases, but I agree most of them has been covered by span. So one of the examples was that we would like to use let's say a method, and one of the typical use cases for unsafe code was using stack alloc, so possibility to allocate something on the stack directly. So we needed to use, for example, pointer to byte if you would like to use stack alloc with the size of, let's say, 16 bytes. And the public unsafe. And this was required because we are using pointer, and since up to C#7 or something like that, we needed to make unsafe to use the pointer to represent the result of stack alloc, but with the help of span, now we are safe, and we don't need to use unsafe at all because of that. Another example is that a lot of Another example was some operations on references or pointers, but we have this unsafe class, which has a lot of very magical methods that also does not require typically unsafe code. So again, a lot of things may be done without the unsafe keyword with the help of the unsafe class. Although the name is unsafe, it doesn't require the code to be unsafe. But still, typically, if you in the end are using pointer to something, then you need unsafe code. Sometimes we still need to refer to pointers in very low level code. So then unsafe code needs to be enabled. Andre, thank you. Those tricks was really cool. Super nice to hear. I hope you will not use them too often, like I'm really afraid some people will start to treat them as a good practices to be pushed everywhere where possible. I hope you feel that, and I mentioned that even a few times, that it is for only some edge cases. But yes, I believe it is super nice to know about them. Which tool do you use to convert C# to IL code? So I'm typically, because it's the fastest approach, I'm using sharplab.io online site, which is just doing exactly that. And in a fast manner, I even can change between the runtimes here and between debug or release mode. So it is super convenient, but sometimes limited. For example, there is a lot of checks whether you can compile something or not in the safe manner in web application like the sharplab.io. So sharplab.io is limiting some things, like, as far as I remember, I cannot use static constructor at all, so I cannot play with static constructors. I can. What was the limitations here that were forcing me not to use? I don't remember, but I don't want to waste your time. But there are some limitations in which you cannot use sharplab.io. So then I'm using Dan Spy as my beloved tool for doing that. Although recently it has been archived, unfortunately, so it is no longer under the active development. It is still available. So DNSpy, you can download the last release and use it. I really like this tool for any way of playing with the compilation. You can even change your code in place and so on and so on. So DNSpy or ELSpy, haven't used it for many years, but it is under active development. So this one is also pretty nice if you would like to use it as a offline tool, like the application you're running on your PC. Just for feedback, your lives are awesome. Super nice to hear that. Thank you, Piotr. And when should I use value task versus task? That's good question. So, and I will try to answer again, in a very short words. So, value task is somehow related to memory management in the end, because it is a struct. So imagine that you have a method that we call do something async, and this is a method that is just obviously async, so it returns something, and let's say it returns an integer as a promise of integer, and it doesn't accept any arguments. And this may have some happy path, like if I'm doing something and I know that something happened in a happy path. For example, I can check here in a synchronous manner that a file exists or something that will respond me fastly. So even before I start real asynchronous operation, I can return a result like 0, let's say. And only if it is not that doing something has happened, I will trigger a real operation. So I will start something that is really asynchronous. So this is typical approach that we have some slow path, no slow path, but happy path, that we have an answer in an synchronous manner, and then we have asynchronous path, probably happening often, most often, but sometimes you know the result even before you can start the real asynchronous operation. And the problem with this approach is that a task is a class. So what is happening here when you are returning, you are creating a task instance just to pass a 0 as a result to the caller, which is a kind of stupid work because the caller will consume it immediately. So you have just created a task that will be immediately not necessary. So it is kind of overhead that we'd like to get rid of. And by the way, the task of 0 is cached, but let's say it is -1 or minus something, no matter. But the goal is that you would create a task as a class and pass it to the caller, and you have just created a garbage that will need to be collected in a moment. So a value task has been introduced as a struct. And the result would be like it is totally the same method, and now it is compiled underneath to a little bit different state machine, async state machine, that will behave the same for the asynchronous pattern. But in case of the happy path, let's say the synchronous path, now you can return this via struct, which is not living on the managed heap. So we will be returned by stack or even register, just to inform the caller that you have this synchronous path, the synchronous answer. So you don't allocate anything to say to pass the result to the caller. So we are, for this happy path, synchronous path, omitting allocation possibility. So that's the case. That's the typical use case. So when asking when you should use value task, I would say that was the intention of it. So passing synchronous answers from value from async methods. And we could stop at that moment, but in the end, value task is so convenient that recent changes to the whole asynchronous machinery in .NET is also able to reuse pooled value task even on that path. So then in both cases you are winning something. In case of the synchronous path, you are not allocating anything. In case of the asynchronous path, you are passing it by pooled value task, which again you avoid allocation. So it seems it is super nice. Okay, so if it is not allocating anything at all, let's now use it everywhere. But that's not the whole story, obviously, because value task has some limits. Value task, for example, doesn't have when all and when any. A value task is limited that it should be awaited only once, not twice or more, because as we know, now it can be pulled. So it should be not good to await it twice or more because it influences the whole flow. So await only once, and so on and so on. So when you start to see the limits of value task, you will see, okay, but in the end, it may be not enough for my particular scenarios. But also, in the end, 99% of use cases will be just fine, or even with those limitations. So again, there is this ongoing discussion whether what should be our default, whether we should use value task or tasks in our APIs. And it is, I believe, not yet decided. So it's up to you. I would say I would really be afraid of giving you any definitive advice. Like, when you know the differences, is now your mileage may vary and you need to decide. I would say if you are writing a regular code that is being called few times per minute, like NIOs to the database or microservices that are not on your hot path, probably all this difference will not matter, and let's just make it any task as always, and everyone will understand. If you start to move to some hot paths, when you are really calling those methods many times, the more hot path-ish the method is, the more you should consider using the value task. That's one of the answers that I can give. Okay. Thank you, Pavel, for nice words. The C# professional is landing very shortly, so stay tuned. I'm super satisfied with some modules that I prepared. So although topics are pretty basics, let's say, we really tried to make more of it than most content you can meet in the internet. So I hope you will be satisfied. Although the question is, are all my videos are available on this channel? No. So in general, the answer is that everything that we are doing is available by this channel, which is Dotnet's channel, or on the products listed on our site. So if you go to the .netos.org, we have currently 3 courses prepared: Async Expert, when I'm a co-author of it, .NET Diagnostic Expert, which I'm helping to author, and also C# Professional when I'm authoring also this course. So we have those 3 available, plus channel on YouTube. Those are the channels when you can meet me. Thank you again for nice and warm words. It's super nice to hear such words, because sometimes it may be a little bit discouraging to see some comments on Reddit, especially when you are posting some nice things and people are just throwing you are attacking you for doing things. So nice to hear that you like it. Okay, so that's all, I believe. If there are no more questions regarding today's webinar, I believe we can slowly end. All those slides, oh, by the way, I will link this, but all those slides will be available on goodies.netos.org, another site. There are slides from the previous series about .NET GC internals, and I will start to publish their slides from this mini series. So goodies.netos.org is the site, and I will post this also in the description of the video, not to for you to be, or maybe I just copy paste it now. So you will be able to find slides there tomorrow, as far as I believe. Okay, forgot Reddit. Yes, I would really like to forget Reddit, but it is kind of really bimodal site. Like, there is a huge number of spamish discussions, but also pretty often, if you have a lot of attention gathered, a pretty big number of really interesting discussions. So it is like those two groups are fighting with each other, and posting there is for me always like, I'm always having hope that I will target those which are doing good discussions, not the bad ones. And after every publication, I will probably stay with publishing there. Just don't care about the results. Okay, so thank you all again. See you in probably 2 weeks or 3 weeks. We will see. So it will be again about something. I have some ideas. I have a lot of ideas what I can cover in this mini series. It is practical series. That's the main goal, to give you some practical advices. So today we have covered pretty spicy things. Less spicy things are also incoming. So bye again. Thank you for being with me. Spread the word about this series. The more people, the bigger satisfaction. And see you in 2 weeks or 3 weeks. Have a nice day, evening, morning, depending where you are living. And see you soon. Bye. And broadcast.